Hi everyone, welcome to day 4 of grade 12 trial exam weeks. They have given us the graph of a cubic graph here, and they are telling us that this is the function h of x. I'm just going to write that as y is ax cubed plus bx squared. Now they're telling us that this graph has turning points at the origin, which is the point 0, 0, and at B, which is the point 4, 32. A is an x-intercept of this graph, but they have not given us the coordinates of point A. Now they're wanting us to show that that A refers to the A in the equation is -1 and B is equal to 6. So now what we're going to do for that, guys, we are actually going to use this point B and we're going to substitute it into the equation, right? So we're going to say that B 432, that point lies on this graph. So I can substitute this point into the equation of the graph. We know that the x value is 4 and the y value will be 32. So I'm going to say a times 4 cubed, because it's ax cubed, plus b times 4 squared is going to be equal to y, but now the y value of this point is 32. Now if I simplify this, it's going to give me 64a plus 16b is equal to 32. I can simplify that. 16 will go into all of those. So if we just divide all of those terms by 16, we're going to end up with 4a plus b equal to 2. Now at this point, guys, we have one equation with two variables. That means that we're going to have to do simultaneous equations, but we're going to need another equation in order to solve for two variables. You always need two equations to solve for two variables. You can't just work with one at a time. Now, the thing about this point, B432, is that it actually also is a turning point. Now, we know that the turning point of any graph, but a cubic graph in this case, happens or is found, can be calculated where the derivative is equal to 0. Now the derivative of this graph, if I'm looking at the equation of the graph that they gave me, the derivative of this expression is 3ax squared. So you take the exponent to the front, multiply it by the coefficient, and then minus 1 from the exponent, plus, if I do the same thing with bx squared, I'm going to take that 2 to the front, I'm going to multiply it by b, and I'm going to subtract 1 from the exponent, and that will be equal to 0. Now guys, look at what happens here. If I now, because this is now just the derivative is equal to 0, but where is the derivative equal to 0? At this turning point, at this x value. So now I'm going to substitute that x value, and that whole equation is going to be equal to 0. Again, because you find the turning point by making the derivative equal to 0. Now this is going to give us 3 times 16, which is 48a, plus 8b is going to be equal to 0. Now, you could simplify that if you wanted to, but I'm actually going to go back to my first equation. I'm going to make b the subject here. Remember that when we are solving simultaneously, you want to make one of your variables the subject so that you can then take that and replace that variable in the other equation by this expression, so by 2 minus 4a. So, like I said, you can simplify this straight away, but I'm just going to sub it in. So 2 minus 4a is equal to 0. If you wanted to simplify, that's perfectly fine. It actually would have been a bit shorter than this, but I'm just going for it. So that's 32a equal to 0. Now guys, 48 minus 32 is going to give you 16, if I'm not mistaken. Yes. So this is 16a. And if we move this plus 16 over to the other side, that's going to give us negative 16. So there we get our a value of -1. This is what they wanted us to prove in the beginning. Now that we have a value for a, what we're going to do with that, to get our b value, we're going to substitute it back into that expression, and that will allow us to solve for b. So therefore, b is going to be equal to 2 minus 4 times a, which we now know is -1. So this becomes 2 plus 4, because a negative times a negative is a positive. So there we get that b is equal to 6.